So we're on samples and populations, problem 1.2, and we just finished in the previous lesson part A where we took the quality ratings for natural peanut butters and did a histogram of those. And now we're going to actually do another histogram, but this time we're going to do it for regular peanut butter. So the regular peanut butter quality. And we're going to do intervals of 5. So this is for regular peanut butter, and the interval we're changing from 10, which we did in the previous one, to intervals of 5. So our intervals in this case are going to go 0, then 5 starts here, and 10, and so on all the way. So these intervals are the numbers there where they begin, 25, 30, 35, 40. So I'm just going to put in these interval numbers on the lines where they starting points. So again, you can see the intervals are intervals of 5. And in just a moment we'll pull the data in here and start charting it on the chart. And so we use so the first time we did the natural peanut butters, which are at the top, and now we're going to do the regular peanut butters that are at the bottom of the chart. So you can see regular, all these down here are regular peanut butters. And we want to look at their quality ratings right here. So here's the quality rating column for each of those. And so let's back this out a little bit so we can see more. So these are the numbers we're going to use, and we're going to chart those on our histogram. And we're going to do them in intervals of 5 and see what that gives us for a result. So this is how you make a histogram using data. And again, always have to determine what intervals you're going to use to do this. So if we look at the peanut butters now and just start charting them off. So if I look at the 76 here for Jif and find where 76 would go. So between 75 and 80. So 80 is there, 76 would be in between. So it would go right there. And that takes care of the 76. And then the 60 would go in the 60 to 65 interval. So these are my intervals. These are the numbers, starting numbers of each interval. And again, I'm just taking numbers right off of the chart. So that took care of the 60. And just keep going with the 54. So 54 goes between 50 and 55. And 43 between 40 and 45. And 40 in the 40 to 45 interval. And remembering that if it's a 40, it goes in the 40 to 45. 35 goes in the 35 to 40. 34 would go in the 30 to 35 interval. 33 in the same 30 to 35 interval. 31 again in the 30 to 35 interval. Again, I'm just checking these off as I go. Two 23s in the same interval in the 20 to 25 interval. So right there, 20 to 25, two 23s, put them in at the same time. The 11, way down here in the 10 to 15 interval. Two 83s, so they will be in the 80 to 85 interval. A 54 in the 50 to 55 interval. 49 in the 45 to 50 interval. 46 in the same interval, 45 to 50. A 45 in the same interval, the 45 to 50. A 40 Remember, if it's a 40, it goes in the 40 to 45 interval. 34 in the 30 to 35 interval. 31 in the same interval. 29 in the 25 to 30 interval. And 26 again in the same 25 to 30 interval. And so that takes care of all of the numbers in my chart. And you can kind of check yourself if you count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 1, 22, 23. Did I miss one? Count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Got them. So sometimes it's good to check and make sure you got all of the numbers checked off, and they're all in there. And so now, as I look at the quality ratings of them, you can once again see that the data clusters for regular peanut butter, so kind of in this general range here, we see most of the data really kind of right in this region for regular peanut butters. And you can kind of even just compare now the quality ratings of the natural peanut butters to the quality ratings of the regular peanut butters. Even though the intervals are not the same, we did intervals of 5 here, intervals of 10 here. When we get to problem 1.3, we're going to look at it one more way, and then we'll be able to compare again and just to see how this sort of works out. But you can see with intervals of 5, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 bars. And one of the questions would be, what's the right number of intervals? And we're going to see later on in this problem where it talks about the right number of intervals is somewhere between 8 and 10. So this one actually has a few more bars than we'd like it to have. It's a little more spread out than necessary. You'd like to be a few less bars, and so intervals of 5 might be too small of increments. We might want to spread it out to 8 and maybe even the 10. If we look at the original problem that was given for this one in problem 1.1, we see where the quality rating bars are in intervals of 10. You can see our count. We have 1, 2, 3, 4, 5, 6, 7, 8 bars, which is kind of ideal. And so this interval of 10 is probably better than the interval of 5, which really spreads out the data. And you can also see the count here on this goes up 1, 2, 3, 4, 5. So our count, our frequency on the side here, which is what we call this. This is our frequency. The highest bar is 5. And so again, we have our range that goes from one part to the other, all the way from here all the way out to here. So there's our range, our spread this way, and then our count in this direction. So this is what happens when we just change the intervals to intervals of 5. Notice how the data spreads out a little bit more, and the data clusters, but it's a little bit wider. It's not quite as tall. We get to problem 1.2c. We'll see that this third part we're going to do intervals of 15 next. In the next lesson, you'll see that and how that affects the height of the bars and the spread of the data in terms of how it looks in the different problems. So that's B, and if you continue on the next part, you'll see problem 1.2 part C. We'll continue to see that.